All right, let's look at how to graph inequalities in standard form, right? So it says the standard form of a linear equation, ax plus by equals c. A, b, and c are real numbers. A and b are both not equal to 0. All right, so it says an x-intercept has an x-coordinate of a point where the graph crosses the, obviously, the x-axis, right? So the x-intercepts where it crosses the x-axis. So if I think about a coordinate plane, here's my x-axis. My y value has to be 0. Right? Every x-intercept has a y value of 0. So an x-intercept looks like this, x, 0. The y-intercept where it crosses the y-axis. So again, here's my coordinate plane. My y-intercepts are right here on this y-axis, which means it has an x value of 0. So my y-intercepts look like this, 0, y. To find the x-intercept, we're going to let y equal 0, because again, an x-intercept must have a y value of 0. I'm going to set y equal to 0 and solve for x. If I want to find the y-intercept, I'm going to set x equal to 0 and solve for y. Right, so example number 1, I have the equation 2x plus 3y equals 6. Right, this is a linear equation. We're going to practice with a linear equation, and then we're going to go to an inequality. Right, so if I was to graph this, I would graph this by finding the intersections, right? So, the intercepts, excuse me. So what I would do is I would plug in 0 for y and find my x-intercept. So if I plug in 0 right here, 0 for y, right? So I've got 2 times x plus 3 times 0 is equal to 6. Well, 3 times 0 is 0. So I've got 2x equals 6. Divide by 2, and I get x equals 3. Now, what did we find? We found our x-intercept, right? We plugged in 0 for y, and we got that x equals 3. So I have a point here at 3, 0. I'm going to do the same thing with my y-intercept, right? If I plug in 0 for x, I'm going to get my y-intercept. So if I plug in 0 for x, I've got 2 times 0 plus 3y is equal to 6, right? I'm just plugging in 0 for x and I'm solving for y. 2 times 0 goes away. 2 times 0 is 0, so I've got 3y equals 6. Divide by 3, and I get y equals 2. So now I have another coordinate of 0, 2. So I know that my line goes to those 2 points. There's your line. Now that's a linear inequality, right? It's in the. So now what I want to do is I want to take these standard forms. I want to convert to slope-intercept form, right? We're familiar with slope-intercept form. M is the slope. Okay, I could say rise over run. And B is the y-intercept, right? B is where you begin. In slope-intercept form, the blank is isolated for. The y is isolated for. So to convert to standard form, we need to solve for y, right? We're going to take our standard form, ax plus by equals c, and we're going to solve for y. So it says, I've got 2x plus 2y equals 8. If I want to move this 2x, I want to get rid of it, so I'm going to subtract 2x on both sides. And I've got 2y is equal to negative 2x plus 8. Now again, our y is isolated for, we need to get rid of the 2 in front of the y. So this is 2 times y, we're going to divide by 2. And we get y is equal to negative 2 divided by 2 is a negative 1, negative x, and then plus 4. Bam. Okay, well now what's the difference between a linear equation and a linear inequality? Nothing, right? We're going to treat them the exact same way. So I'm going to subtract 2x on both sides. I'm going to get the y by itself. So I've got 3y is greater than negative 2x plus 6. Last step, I'm going to divide by 3. And I get y is greater than negative 2/3 x plus 2. Perfect. So I have one rule when dealing with an inequality, right? It says when dealing with inequalities, when you multiply or you divide by a negative number, you must flip the symbol. Right? So that's our one rule with inequality. If you multiply or divide by a negative number, you flip the symbol. Alright, so example 4 and 5, we're converting to standard form. We're solving for y. So let's subtract 4x on both sides. We get 2y is greater than negative 4x plus 12. Divide by 2 to get y by itself. And I get y is greater than negative 2x plus 6. Right here, I'm going to subtract 3x on both sides. I've got negative 9y is less than or equal to negative 3x plus 18. Alright, now I want to divide by a negative 9. And again, when I multiply or divide by a negative number, we flip the symbol, right? So this was a less than or equal to. It's going to become greater than or equal to. So I flipped the symbol. I've got a negative divided by a negative. That's going to give me a positive. 3 divided by 9 is 1/3 x. 18 divided by negative 9 is a negative 2. Alright, now let's look at how to graph these puppies. So let's remember our rules for graphing an inequality. If I've got a less than or a greater than symbol, okay, a less than or a greater than symbol, notice that there is no line underneath, which means it's not equal to. There's a difference here. These are equal to. This is less than. This is greater than. This is less than or equal. And this is greater than or equal. So if they are equal, they're solid lines. What that means is that all my solutions on that line are included in my solution set. Now if they're not equal to, they are dashed lines. Anytime I have a less than symbol, I'm going to shade, this is shaded, I'm going to shade below. So then the opposite would be true for greater than symbols. I'm going to shade above for greater than symbols. Alright, so let's graph this first inequality here. So it's already in it's already in slope-intercept form. I've already got the y isolated for. So here's my b, there's where I begin, so minus 1. Now from there we're going to go up 2 over 1. If I look at the symbol here, it's a less than. Okay, well less than tells me that's a dashed line, which means that no points on the line are solutions. And if it's less than, I shade below. So here's my y-intercept. I'm going to go down on the y-axis, and I know I'm shading down here. So I shaded below the graph, which means that all those points that I'm shading in right now are solutions to that inequality. Right? We have multiple solutions. Alright, so example 6, 7, and 8, we're going to convert to slope-intercept form, and we're going to graph. Right? So I'm going to subtract x to get y by itself, and I get y is less than negative x plus 2. I'm going to start at my b, my y-intercept of positive 2, so go up 2. From there I'm going to go down 1 over 1. Now it's a less than symbol, so if I go back up here, less than tells me it's dashed, and I'm shading below. So I'm going to connect these dots with a dashed line. And again, that means that none of those points on the line are solutions. And if it's a less than symbol, I shade below. So here's my y-intercept, go down, and I'm shading down here. And again, that is your solution set, right? All those are solutions to the inequality. Number 7, I want to get y by itself, so let's subtract 2x. I get negative 5y is less than negative 2x plus 10. Alright, now I'm going to divide by a negative 5, and again, when I'm dividing by a negative, we're going to flip the symbol, right? So y is going to become greater than. Instead of it being less than, it flips to be greater than. So y is greater than positive 2/5 x minus 2. 10 divided by negative 5 is a negative 2. So let's go down 2. From there, we're going to go positive 2 over 5, so up 2 over 5. Let's do it again, up 2 over 5. And I'm going to connect those with a dashed line. It's greater than, it's not equal to. Dashed line. And it's greater than, so here's my y-intercept. I'm going to go up on the y-axis, and I'm shading up here. Last one, let's convert this. So it's minus 4x. I get negative y is greater than or equal to negative 4x plus 2. Alright, now I'm going to divide by a negative 1 because I need the y by itself. So we're dividing by a negative 1. It's going to become y is less than or equal to, because I divided by a negative. Negative 4 divided by negative 1 is a positive 4x. 2 divided by negative 1 is a negative 2. So my b, my y-intercept, is negative 2. We're going to go up 4 over 1, up 4 over 1. And we're going to connect them with a solid line, right? Less than or equal to. If it's equal to, we make a solid line, which means that all the points on that line are solutions. If it's a solid line. If it's less than, I'm going to go underneath the y-axis, or underneath the y-intercept, excuse me, and I'm going to shade all these points down here.